I'm going to build this out in several stages. The first stage, I'll create a namespace, this outer box. Then I'm going to create a pod. When I create the pod, although we're not going to use them in this episode, I am going to create my pod with labels. Labels are a really important concept in Kubernetes. They can be used for finding pods, but more importantly, they're used by higher level abstractions to decide what pods they're in charge of managing or what pods they're providing access to. So we'll talk about that in later episodes. At the center of my pod, I've got a single container. This single container is using the MySQL image, and my lab, which by the way is on the opposite coast of the United States from me and is all virtual and shared. Just pointing out that in your environment, these things might run quicker. My lab is pointing at hub.docker.com, and on hub.docker.com, the image I'm after is MySQL. And what I've done is I've just gone to that web page because there's some information in here, including this environmental variable, that we'll need in order to get our container up and running. So I'll have a look at the YAML file that defines our pod, and our first version of this pod, you can see these are the labels that I mentioned back here. Then we get into the specification, and I've got one container that I'm going to instantiate, and the image, of course, as we just saw, MySQL. This particular version, MySQL requires that the password be set on the database, and so I'm going to expose this environmental variable to the container, and I'm going to say that my password is simply password, so not super secure. And this will be the first thing that we fix in version 2. The other interesting bit here is the network information, so I'm going to expose this port on TCP. Restart policy, this says if the MySQL process stops running, that container goes away, I want Kubernetes to restart it. So restart always, and in the demonstration I'll show how that works. Termination grace period seconds. With regard to any of the stateful workloads, whether they're databases or monolithic apps, Kubernetes uses a two-stage process for termination of workloads. First, it'll send a signal to the process telling it it needs to stop. And then termination grace period is how long Kubernetes will wait for that process to shut down cleanly before it pulls the rug out from under it and actually does a kill-9. So in any of these stateful applications, because you often need to flush your state from memory to disk, setting the termination grace period is a good thing to do. And 30 seconds is the default. The only reason I've popped it up here is to point it out. First thing we're going to do is create that namespace, and I'm going to call that namespace EP2. In order to make use of EP2, I'm going to apply it to my configuration. So then I'm going to switch my context so that I'm within my namespace. Next, we'll actually create our pod. If I do a kube control get pod, we can see that we've got our HR database 1 up and running. What we'll do is we'll jump into the pod. All right, so if I do a PS, we can see that this is our main process running as MySQL. SH is what I've kicked off here. right? And then the command that I've just executed. Next, what we'll want to do is start the MySQL client. Log in as root, and of course, all right, so we're logged in here, and we can say show database. In our example here, we've got an HR database, so we need to create it. So we're going to create a database called info. Then we're going to say use info, and then we're going to create a new table, and I'm going to cut and paste this because it's long. And we're going to insert some people into our HR database. And then of course we want to select info from our team, and there's the people that we just added. So we've got a container, we've got MySQL up and running, everything's looking good. So I mentioned this restart policy always. What I wanted to demonstrate was a crash of MySQL. Obviously MySQL is very solid, so it's difficult to get it to crash on its own. So what we're going to do is sneak behind the scenes here. What I've done is SSH'd to one of the worker nodes, the worker node that happens to be running this particular pod. So we're going to kill the container kind of behind Kubernetes back and make sure Kubernetes restarts it for us. So what we can do is a docker ps and look for our, so here's the container that's running the MySQL image, of course just started a few minutes ago. Here's the pause container, and that also started 2 minutes ago. So what we want to do is we want to do a stop on both of these. And so that's killed those two containers, but what we'll see if we flip back to our Kubernetes view of the world, it's still running, but now my restarts is 1. So Kubernetes noticed that the containers making up that pod failed, and it restarted them for us. So it might not be obvious, so I'm going to point it out here. We're going to jump back into that container. When we killed the containers that make up this pod, because those containers don't store any state, we lost that database that we created. And I'll show you what I mean by that. Show databases. You can see that our info database is gone. And obviously the table we created in that database is gone, as well as the records that we've put in there. So this obviously is not a good idea. And so by the time we get to step 5, we'll be able to keep the state, hang in there while we fill in a couple of other gaps.